This lecture is being brought to you in part by the generous gifts of these sponsors.
Thank you, Bonnie, and thank you all. Wow, what a crowd. This is really a pleasure and an honor to come here and speak to you tonight. I met Ken Ford a couple of years ago, and I greatly respect his personal story and also the type of work that you're doing here at IHMC. So it's a pleasure to come here and talk to you a little bit about what we're trying to do in this important field. And I'm sure that many of you, by the color of your hair, are thinking quite seriously about this question that's on the screen. So let me start by saying that this is what the view from my living room window is like. It's not quite Florida, but it's cold up there now, and it's a wonderful place to do winter sports if that's your thing. Let me show you where we are in relation to you. I chose this form of projection of the map of North America so Canada would look even bigger than it. But it's mostly empty up here. And I don't know what the distance is exactly, but we're up here north of Boston, about 4-hour drive north of Boston, out a little east of Montreal. So that's where Sherbrooke is, and who would want to go to Sherbrooke out in this sort of countryside, a bit like Ocala in relation to Orlando, I imagine. It's because they do very good imaging research in Sherbrooke, and because they have an excellent research center on aging, and my personal life brought me back into Quebec, where I actually grew up, but the first part of my career wasn't there. I want to start by making my disclosures. We have funding from the public sector, government agencies like the Alzheimer Association here in the USA, and Canadian agencies of various sorts. And the private sector funding as well, which has helped us do some of the work we're doing. So I've got lots of conflicts of interest. I think we all have conflicts of interest. We all have commitments and beliefs in certain ideas, and I hope that my support from these organizations has not colored the way we see this story. I think every story needs a beginning, and I think it's important to start with some of the pioneers in this field. John Freeman died recently. Has anyone heard of John Freeman? So John Freeman, as I mentioned here, was responsible in a big way for reviving the ketogenic diet for intractable epilepsy, particularly in children. George Cahill also was a pioneer in this field and died recently as well. He was the one that really put ketones on the map because they'd known for a long time that something was helping run the brain besides glucose, but no one really knew what it was until the late 60s when he did some fairly radical experiments that we probably wouldn't be able to do today. But we've done them, and we've benefited a lot from the work that they did. I don't know when Bud Veach was born, but he's still alive, and he's doing some excellent work on this area as well. He was a student of Hans Krebs from the Krebs cycle, part of the cellular machinery that generates energy. And so he's an important player and has been very active and vocal in this area and helping give ketones some solid scientific credibility. This is a name you might not recognize, Mia Kivipelto, but she is a pioneer as well. She's younger than these old farts that are higher up. She's a Finnish lady, a neurologist, and she ran the finger trial. So if you Google finger or finger trial, it would be better because you might learn about other fingers besides this trial. You'll find that this is the main, in my view, and I'm going to finish the talk referring to this trial. I think it's the most impressive prevention-type trial to slow down cognitive decline in older people. It's not on Alzheimer's disease, but it shows that a concerted, multi-pronged approach to prevention can be beneficial. And that's my take-home message, and come to that towards the end. So let's look at the brain, and this story is about brain energy metabolism. It's about brain fuel, and this is a simple cartoon to try and give you an impression that the brain is kind of like a hybrid car. The brain is running not on electricity and gasoline, but on glucose and ketones, and it's keeping that process running properly that is a challenge as we get older. It's a challenge to get the main fuel, which is by far glucose, into the brain. And it's a challenge making the switch, because if you're in good health, then your body is making that switch all the time. But people who are at risk of Alzheimer's because of type 2 diabetes, insulin is a bad guy in that situation, and insulin is blocking part of this process, a point that I hope to get to as well. So try and keep in mind that what we're talking about is fuel, and we're talking about a hybrid brain that's running on these two fuels. I'm not a chemist, but I'm going to have to show you just a little bit of chemistry, very simple, to identify these molecules. When we talk about ketones, we're talking about ketone bodies, which is the old term, shorten it to ketones, that are generally derived, not exclusively, but generally are coming from our dietary fats or our stored fats. And the first one that the body makes when they are being produced, primarily in the liver, is this molecule called acetoacetate. And it is in this two-way arrow means that it's in a balance with the one you can measure with these finger prick tests that you can do with certain devices. And this is beta-hydroxybutyrate, just a small chemical difference between the two. And there's some degradation of acetoacetate to acetone, which is the same molecule as in nail polish remover. Your body's actually producing the same molecule and in relatively high concentrations, about the same concentration. So this is not a negligible product. So these are the main ketones. There are some others but they're not really relevant to our story. So what I want to do is give you three, for me, guiding principles around ketone biology in the brain. The first one is this thing that I call the push-pull story, because there are two strategies to get energy into the brain. This tube here on the left is the blood, and this rectangle on the right represents the brain. And this little stick person here in the middle is pulling glucose into the brain. It's the pull part. And why is it working that way? It's because he's activated, or she is activated by the fact that glucose will go down when that cell has done something. It's talking to its neighbor. And so when the glucose goes down in the blood, the transporter is activated, and a molecule or several molecules of glucose are pulled into the brain. If this cell is not very active, then this process doesn't happen. And that's normal, that's fine. But it's the opposite to what happens with ketones. Ketones don't care how busy this cell is. When the ketones go up in the blood, they are pushed into the brain. They are the backup fuel for the brain. And that's an important mechanism, because if glucose starts to go down because you've been fasting, you may have been sick for a few days, or something like this, there's less glucose available to do this, ketones will start to go up, and they need to get into the brain quickly. So they don't hang around for a signal from the brain. They are pushed in right away. And so the two fuels are quite differently managed in the body. And the advantage for us is that we can provide more ketones, and we can be pretty sure they're going to get into the brain, at least into the normal brain. We'll come to the Alzheimer brain in a minute. The problem, partly too, is related to glucose. No, I'll leave that point till later. So that's the first point. There are two strategies. We have two major fuels in the brain, and there are two very distinct ways on which they get into the brain. One gets pushed in, and the other gets pulled in. The second point is that this is a concocted image, actually, of a fetus. It's actually a human brain that's been projected into the head of this infant, but I think it's a dramatic image to remind me, to tell you that ketones are helping run the infant brain all the time. They're not the only fuel that goes into the brain, but the infant's brain is very large compared to its body, as you can see from this image, much larger than ours as adults. And this brain absolutely depends on ketones day in, day out. It's not a question of being sick and there's not enough glucose and oh, ho-hum, we'll use some ketones. It's an essential part of that baby's growth and development every single day. And where do the ketones come from? A little bit from the fat, and this is a pretty skinny baby. But mostly from what source? Do you know what source? Where do babies get ketones from? From the milk, from the medium chain fatty acids in the milk. And there's lots of medium chain fatty acids in the milk. So when we talk about potentially using ketones to rescue brain function in older people, what we're trying to do is basically recapitulate the situation in a normal, healthy baby. This is not a baby that has a disease or that's been stressed or that's fasting. This is its normal, healthy development. So we're just trying to recapitulate physiology of the baby in an older person. And the third point in this context, which might look a little challenging to understand at first, is that ketones are the brain's preferred fuel. And I underlined it because that's what I really mean. They're not the main fuel in the brain, but they are the preferred fuel. How do we know that? If we put people into nutritional ketosis, so if you start taking a ketogenic diet today, 4 days later, we did these analyses. And we showed this term down here means, this x-axis means that it's the change in ketone uptake by the brain. The delta means the change, and the numbers have all got a plus on them. So they've gone up from what they were before the ketogenic diet to afterwards. And this is called an inverse relationship, which means when this number goes up, this number is going down. It goes from around -5 down to about -10. So the glucose is here on the y-axis, and the glucose uptake goes down in direct relation to the amount of ketones that are available. That might seem counterintuitive, but in fact, the brain only needs so much energy. And if it's got a choice between ketones and glucose in a young, healthy adult, it's going to choose the ketones and hold back on the glucose. So we want to exploit that, and that means you're conserving the glucose for other things that glucose can do besides simply fuel the brain. So this is an important concept. There's not a lot of ketones in the blood. We can push that up, but when they're available, they're actually the preferred fuel. And I'm going to come back to this point at the end because it has relevance to Alzheimer's. So let's talk about this story of brain fuel in Alzheimer's disease. What is the problem? These are called PET images, PET scans, and the control brain looks typically like this, where you have the areas that are really using a lot of glucose are on the red to orange color, and the areas that are not using any are in the blue. So it's a rainbow of colors. The blue areas are blue because those are the ventricles. They contain liquid, they don't contain any cells, so they don't use any glucose. So that's a normal PET scan. The problem we've known about for nearly 40 years now, since the dawn of PET scans in the late 70s, is that two areas where these arrows are, which are called the parietal lobes, over the ears, are not using glucose very effectively. So we call this brain glucose hypometabolism. Hypo meaning lower than normal. This is a signature of Alzheimer's disease. It's not a diagnostic tool, but it's almost always observed. So the question is, have the cells died there and they're not using glucose? Or are the cells actually alive, but they're not able to get or utilize the glucose very effectively? Is it the cart or is it the horse? Obviously, if they've died, then the ability to use glucose has got to go down. So we started to look at this, and our concept is that the brain energy deficit precedes the cognitive decline in people that don't have Alzheimer's but are at increased risk of Alzheimer's. The yellow box refers to these people who are at increased risk, who have lower brain glucose uptake. It's called latent presymptomatic brain glucose hypometabolism. That's an earful. It's latent because it's very low key. It's presymptomatic because there's no cognitive symptoms in these individuals, no symptoms of cognitive deficit. Who are they? Older people, me included, lower brain glucose uptake, people with insulin resistance. It's not just older people. I'll show you an example. People with a family history of Alzheimer's disease, people that are carriers of what's called the E4 allele of apolipoprotein E, and the presenilin carriers who are by far at the highest risk. They are basically guaranteed to get Alzheimer's because of the mutation they have. In each case, these are people that have been studied before they have any cognitive symptoms. And guess what? They all have this pattern of glucose hypometabolism. It varies from one of these conditions to the other, but they all have a problem with energy before they get to the disease. So let's put this into context. They've got some problem with glucose. It's our concept. It's our concept. This is helping contribute to the problems in the brain, the deterioration of the synapses, because the brain is running on 10 to 15% less fuel than it should be getting. It's like trying to run your car on 3 cylinders instead of 4. It's not going to work very well. And this in turn leads to the cognitive decline, and eventually some of those cells are going to die, and the glucose uptake is going to go down, and we develop a vicious cycle of brain energy exhaustion and progression of the disease. Now, this is just an idea. It's a concept. And if I go to the Alzheimer Congress, as I did last summer, there's almost nobody who's going to agree with this. So, you can put a concept up before people, or you can test it. And one thing you can do is test what is happening to other fuels like ketones. If those cells are dead, they won't be able to use ketones, right? So let's look at that idea again. Either the brain cell is not able to use glucose or it's dying. So this is my imaginary brain cell. Both situations have low glucose uptake. But if the cell is dying, it won't be able to use ketones either. Would you agree? If it's starving, we'd be able to see it should be able to use ketones. If you're hungry and your body will be using ketones, and your brain, a person can starve for over 30 days, and the brain will be running predominantly on ketones. So the fact that you've been starving was not going to prevent the brain from using ketones, that's for sure. So if you've got a PET scanner for the glucose studies, this part of it, you need to be able to do the same measurements with ketones. And that's what we developed in our center in Sherbrooke. So we looked at these types of scans and we compared them in people that were at risk of Alzheimer's or with Alzheimer's disease, and then we compared them to the ketones. And this is an overview of the results we saw. So brain glucose and ketone uptake in Alzheimer's disease and in mild cognitive impairment. So mild cognitive impairment is MCI, and Alzheimer's is abbreviated as AD. Do you see a difference in the colors from the top to the middle to the bottom? Maybe the people in the front. Shout out what you see. Do you see more green at the bottom or more red? There's more green at the bottom. And what does the scale show you? Maybe you don't see the scale very well, but green is towards the bottom of the scale and red is towards the top. So that means that the Alzheimer brain is using less glucose. Okay? We're not the first people to show that. So I showed you a slide of that earlier. It was a cross-section of the brain. This is what we call a surface projection. But this is confirming that our PET scans and our people with Alzheimer's, unfortunately, have what you would expect to see, a problem getting glucose into the brain. So what do you see on this other side? It's the ketone story. There's green here, but there's a little less green here, a bit of yellow, and there's even a bit of orange and perhaps a reddish color at the bottom. That means that the Alzheimer brain is actually taking up ketones better than the control brain, and these are age-matched individuals, men and women. So there's no problem getting ketones into the brain, and there is a problem getting glucose into the brain. Now, these people were not on a ketogenic diet, they weren't on a ketogenic supplement, they weren't on a ketone salt or any of the ways you can supplement your ketone. They weren't fasting. So the question became, well, let's just summarize that result first of all, to come back to our example. If the cell was dying, then the ketone uptake would not be normal, but it is. So we can, initially at least, eliminate this question of, is the brain cell dying? Is the glucose uptake problem due to the cell being dead? No, because ketones are getting in normally. So this gives us a chance to explore a therapeutic effect of ketones. The question then for us was, can the Alzheimer brain use more ketones when they're available in larger amounts? Because if we go back quickly to this image, this is under normal circumstances. Your brain is using 1, 2, maybe 3% of its energy is coming from ketones. This is very low levels. If we're trying to correct this problem with glucose, which is on the order of 15 to 20%, we're going to be able to get more, we need to get more ketones into the brain. And this slide shows in a kind of a graphical way that when you raise plasma ketones in people with Alzheimer's disease, plasma ketones have gone up from 0.4 to 0.8 on our treatment. The brain ketone uptake is shown on the y-axis, and this faint dotted line in the background is our healthy young controls. This is the relationship that would be the ideal situation. And where do these two lines fit? This is called the pre-point. That means before they started a ketogenic supplement. The post is after they started the ketogenic supplement. We've only got data for 7 in one of our medium-chain triglyceride supplements and 11 for the other. But these two lines are stuck to the reference line. So the bottom line is that when you provide more ketones to the Alzheimer brain, it can use them, which is neat. This is what it's all about for us. If that line wandered off here somewhere, it would suggest that you raise those ketones like crazy in the blood, but the brain's not able to use them. So far, so good. Let's look at what happens before you get Alzheimer's disease. That's the condition called mild cognitive impairment. And looking at people that have been on a 30 gram per day medium-chain triglyceride supplement, this time for 6 months. So this is a study that we not only had a relatively long period of time, we also had a placebo involved, because now we're getting to think that we've got a chance to do something interesting here. We've got to do this right. We've got to compare it to a placebo. There's quite a placebo effect in treating people with memory deficits and cognitive problems as they get older. When we look at the brain, what's happening to the ketone uptake? It's similar whether they're on the placebo or on the, before they start. Pre is before they start the placebo or the MCT treatment. Doesn't change after they took the placebo. The two blue bars are obviously the same, but it's doubled on the MCT. So this again shows that the mild cognitive, obviously if people with Alzheimer's can use ketones normally, we would have expected this to be the case in MCI, in mild cognitive impairment, and we have these data, and we've got twice as many people. There's 19 people per group. So our data are a little more robust right now. And if we come back to that sloped line, we've collected a lot of data over the years now, not all of it being ours. In fact, some of these data out here at very high plasma ketones were people who were starving for 60 days. These are published results. They all survived, by the way. They were in medically supervised weight loss, fasting for weight loss. But the point is, the relationship between the plasma ketones and the brain ketones follows this line, whether you've got very low levels of ketones or very high levels. It's a very straight line. It never seems to hit the ceiling. The capacity of the brain to extract ketones from the blood is phenomenal. And our MCI are exactly on the same slope. The line is offset, the blue line is offset a little bit because we measure acetoacetate, and these are measures of beta-hydroxybutyrate, and the uptake is not identical in the brain. But what matters is the slope is the same. So it shows that if the issue is to get a little more in, all we need to do is raise the plasma level a little bit more. And that was a very encouraging result for us to see. So let's say you're working for the regulatory agencies. What's the regulatory agency here in the US called? The FDA? And you've got a new ketone product that you would like to be able to get approved for cognitive issues. Pretend you've got responsibility to FDA for making this decision. So I think the question you're going to ask is, who cares about whether ketones are getting into the brain? That's not the bottom line. The bottom line is, well, I care too. But the bottom line is, does it solve a memory problem or not? Correct? That's my point. I'm being a little bit facetious. And so what we need to do is look at some of these tests that people do. And maybe this is not as big as it should be, but there are tests of what's called episodic memory. There are tests of executive function, processing speed, working memory, attention, and so on, language. And we've administered this battery of tests in the study that I just referred to. And the results, generally speaking, look like this. The MCT being the active treatment, and an upward-facing arrow is a positive outcome. The yellow is a negative outcome, and there are some positive, modest positive effects even in the placebo group. So we've done an important battery of tests, and we've looked at people with MCI, 6 months on the MCT, and we're seeing some trends that are interesting. The next and critical step is to, you probably can't see it at the bottom unless you're up at the front here, but the next step is to expand the sample size, because I showed you the results for 19 people. Well, 19 people in the placebo group and 19 people that complete the study. In fact, we recruited 54 people. That's a $750,000 study to do over 3 years. That's a lot of money, and we appreciate the investment, but all we could study was 19 people that actually finished the treatment. So these are trends, some of which are significant with the bigger, fatter arrows, but a neurocognitive specialist would look at data and say, well, you've got a statistical difference with 19 people, but it's not enough. So we're going to try to do a larger study now, and this is called a proof of principle study. We've got some very encouraging results, but they're not definitive. That's not going to stop any of you that wish to using MCT at home. If you choose to, they're approved by the FDA, and our FDA in Canada is called Health Canada. You can buy them, as I'm sure many of you know, off the internet or at your local health food shop, and you can experiment with them safely and with some hope that you might see some beneficial effect. I'm not selling any product here, but I'm telling you that this is enough to, you could wait 5 more years. Some of you might not have 5 years to wait, so you've got nothing much to lose to give this a try. Another thing that you're going to do as the FDA representative handling this file is to say, who else has done work in this area? Who else has found something interesting? They call it external validity. Is there something weird going on in Sherbrooke, Quebec, Canada that doesn't happen anywhere else? Well, it's a fair question. So has anyone else seen the same beneficial effect of ketones on memory in older people? And the answer is yes. The ketogenic diet has been used in a couple of studies. Robert Krikorian used it and published the data in 2012 in a randomized controlled trial. I think he finished with 12 or 14 people per group, so an even smaller study than ours. Russell Swerdlow has a paper that is actually just on PubMed now, I think, that was just published with, I think it's 15 people, no placebo group, so it's not a randomized trial. It's simply ketogenic diet. How many people have tried a ketogenic diet? I see maybe 20, 30 hands go up. So you know that that's a challenge. It's a change in your lifestyle completely, right? He had these people stay on it for 3 months. It also took him 5 years to get 15 people to complete the study. So it might be an excellent solution, but is it a practical solution? We don't know. Suzanne Kraft is doing work on this right now, and I haven't seen any progress reports from her group. Sam Henderson, working for a company called Axera, published a paper nearly 10 years ago now, which was a randomized controlled trial as well, with a modestly interesting effect of the MCT called caprylic acid, or C8. He then tried to reproduce it and was not successful. And we have a work in progress. So one of the questions is, I think that it's clear that we can get more ketones into the brain if we try. So it could mean that you can get all the ketones into the brain you want to, but the effect on memory is not so simple, even though we see what you call a straight line relationship with some cognitive scores. So it could be that you might get some improvement, but it's never going to get much better. Or it could be that it depends on how much ketones you get in, the amount of ketones you get in, the dose, in other words, of your ketogenic product. So I've got a little bar graph to show you that gives a little bit of an idea of what I mean. In the sense that over here on the left are cognitively normal young people, and the dotted line here at the top is 100%. So what is their brain running on? It's running 97% on glucose and 3% on ketones, approximately. Your cognitively normal older person is, got a 7% deficit here. Not in ketone uptake, but glucose levels have gone down. The uptake of glucose has gone down by 7%, still cognitively normal. The person with mild cognitive impairment, not taking any supplement, it's gone down a little further, 8-9%. Ketone uptake's still normal. The person with mild cognitive impairment, like in our 6-month study, taking 30 grams a day, we've got more ketones. We've increased the yellow bar quite significantly. But we've still got a deficit. 30 grams a day does not replace the glucose that's not getting into the brain. So over here on the right, we've calculated that we think it would take at least 45 grams a day in order to meet the brain's energy requirements and bring it back, in terms of energy, to that of a younger adult. So that is the brain energy gap. The young person doesn't have a brain energy gap, but as we get older, we all have a brain energy gap, and some of us can fill that gap with ketones if we take a ketogenic product. So that's the work we've done with Alzheimer's disease and with mild cognitive impairment. We're still at what you would call the proof of principle stage, and we're pretty encouraged, but we've got a long way to go still. One of the things that's important to think about is to come back to this balance. And I was about to tell you at the beginning about insulin, and I decided to wait until now. Because one of the main factors for Alzheimer's disease as we get older is type 2 diabetes. And what is type 2 diabetes? Basically, to boil it down, it's because we're not very active, and it's because insulin is not doing its job very well. Insulin is trying to get glucose out of the blood, but it's not able to because you're eating every day and a fair amount of refined sugar, and insulin's trying and trying, but it's getting tired and it's not working, and it's there and the pancreas is pumping out more, but it's not working very well. And I mentioned in one of my conceptual vicious cycle slide that people with insulin resistance have got a problem getting glucose into the brain. Well, the problem with insulin is that it screws up the glucose entry into the brain, but it also prevents the ketones from getting into the brain. It prevents the body's fat tissue from releasing the fatty acids that are used to make ketones. Now, you're probably confused. Medium-chain triglyceride that you take as a supplement is going to make ketones, and insulin's not involved. But if you fast or if you're on a ketogenic diet, the ketones are coming from your fat stores, and insulin is blocking that. So basically, insulin puts the brain in double jeopardy because its two main fuels are now not getting in properly. Well, insulin resistance is not just something that happens in older people. Here's an example of young women, 24 years old, with a form of insulin resistance due to polycystic ovary syndrome. They're 24 years old, and these patterns of color here are the areas where the brain is not using glucose properly. One of them is this big red area, which is the frontal cortex, where they have at least a 10% deficit. The green and blue are the temporal and parietal cortex, parts of them, where there's about a 10% deficit as well. This is strikingly like what you see in someone 65 years old, but they're 24 years old. And so insulin resistance is not just a function of aging, it's affecting the way the brain is using fuel independently of age. So we've got to try and reduce insulin resistance. If you think prevention, you've got to take care of insulin resistance. You've got to make insulin work better. And one of the approaches that I think was successful in this regard is the Kivipelto study that I referred to. The title in the paper was a 2-year multi-domain intervention of diet, exercise, cognitive training, and vascular risk monitoring versus control to prevent cognitive decline in at-risk elderly people, a randomized controlled trial. So they're at risk, but they don't have Alzheimer's disease. It's a randomized controlled trial. How do you randomize? Well, you can randomize, but how do you control for diet, exercise, cognitive training, and vascular risk reduction? That's a big challenge, but it can be done. They give them standard of care, which is try to eat a better diet. Versus, this is exactly what you should do, because telling someone to eat a better diet is going to go in one ear and out the other. If they're in a randomized controlled trial, well, you don't want them eating a much better diet, because then they're going to be doing like the active group. But this is a very challenging project. They had 1,200 people complete this trial, 600 on the active arm and 600 on the inactive arm. And just to remind you of what these interventions were, physical activity 3 times a week. The cardiometabolic risk reduction is basically get the insulin down. The cognitive and social stimulation was done together, so people were learning how to use computers, and people were doing things together, socially but cognitively as well. Playing bridge, for instance, is social and it's cognitive at the same time. Better nutrition was personalized. They made measurements of the vitamin status, the omega-3 status, and they said, well, this person needs more omega-3, they get a supplement. This person doesn't, they don't need to. This is a complex approach. It worked. Actually, the placebo group improved somewhat, but the active group improved even more. So this showed 91% of the people that started this study completed it. And it's a 2-year intervention. Most of the time, the gurus in the field said, prevention doesn't work. And even if it does, nobody's going to do it. Well, that's not true, because this shows that it can be done. And what we want to do in Sherbrooke is add this red bar at the bottom, which you can hardly see, but to add a ketogenic supplement. Because the one thing I think they didn't do is provide a better supply of brain fuel. You can reduce insulin resistance, which is a great thing to do, but that doesn't get more glucose into the brain. That problem doesn't seem to go away. And the only way I think we're going to get more fuel into people is to get more ketones in, and we're going to call it keto finger. We just need $10 million. But apart from that, we're ready to go. We're at the starting line, ready to go. And you know the neat thing, I didn't mention it, but the neat thing about physical activity, we've done a study of the brain ketone and glucose uptake. Physical activity in Alzheimer's disease increases brain ketone uptake. So if we give them a little MCT or some other ketogenic supplement, plus the exercise, we have a better chance of getting the ketones in than we will with either one alone. And that's part of the recipe. This is an essential recipe to improve your chances of staying cognitively healthy longer in life. So I will finish by saying thank you. And as the British say, if you've been on the London subway, the tube, mind the gap. Thank you. How did we do?
Thank you, Stephen. We have time, about 15 minutes for some questions. So Christy's got a mic back there. Wait for the mic, please. Okay.
Dr. Cunnane, my wife was diagnosed 10 years ago with mild cognitive impairment. 2 years later, that diagnosis was upgraded to AD. Her neurologist put her on Axeris product, which, as long as it was available, seemed to work quite well. But 6 months ago, the trial failed and it's not been available. Since then, we've been using ketone salts. Started at 13 grams per day. We've upgraded it to 26, along with 4 tablespoons per day of coconut oil. And that seems to really be doing the trick. If there's something more we should add, tell me about it, please.
Well, congratulations, first of all, because it sounds like you're helping to slow down the progression, which is all I was asking in my title is, can we slow it down? I think you've given us an example that maybe we can. I would encourage you, ma'am, to try and do a little exercise. I'm sure you're thinking about that. I think it's going to help make those ketones, whatever dose you can take, it's going to make it more effective. Try and stay in your social clubs, your social activities as much as possible. Get that stimulation, get the brain cells talking to each other, and good luck. I don't know who's...
One of the things I've been looking into is certain things related to anti-aging, and as well as good health. And one of the things I've read about is the drug metformin, which people with prediabetes are taking. And also, it appears that people who do have diabetes that take it may live longer than people who don't take the drug. So I'm curious about alternate ways of solving the AD.
I think it's a great idea because what metformin is helping do is make insulin function better, helping get rid of some of the glucose that's present. If you do a search, have you heard of PubMed? Do you know that this is the way people look for scientific articles? I was a little alarmed when I looked at, when I did a search on Alzheimer's disease and metformin. There are some positive results, but they're not all positive. So I'm not here to be alarmist, but I'm not sure that metformin is part of the solution. There may be some pharmaceuticals that are going to be helpful, and I don't want to worry you, but I think you need to talk it through with your physician. I'm not here to give personal advice for sure. Maybe metformin is part of the solution in your case, but maybe not. It's something we need to find out. I think if you can use exercise, it's going to help regularize insulin as well, and that's what we should do as much as possible.
A few years ago, IHMC sponsored a talk by Dr. Newport, I think her name was, and she reported on a study she had done. It's anecdotal at best because she only had one patient, and that was her husband. And she started him on some serious doses of medium-chain triglycerides with remarkable results. And I was just wondering if you know who she is or know of her study and what the update on her husband's status is.
Well, I do know Mary Newport moderately well, and I'm quite familiar with the case of her husband. As you say, it's a case report. She had a combination at various times of coconut oil, or plus or minus MCT with a ketone ester that was developed by Bud Veach at the NIH. And there were phases when he was on a drug treatment that was under development at the time. So I'm not sure what to make of it. Was coconut oil actually beneficial? If coconut oil is beneficial in Alzheimer's disease, and I'm not saying it isn't, I think each person is going to find out. Nobody's done a controlled clinical trial, so we don't know. What we do know is that coconut oil does not change your ketone levels. I'm going to repeat that because I'm sure it's going to surprise some of you, but in our experience, short-term studies, ketones do not go up because the active part that makes the ketones is particularly the 8-carbon fatty acid called caprylic acid, C8. And there's only about 5% of coconut oil is C8, roughly. So there's no way that it's going to be very active in terms of making ketones. That doesn't mean it's not doing anything for the brain. And so the jury's out on that. Is anyone going to invest in doing a controlled clinical trial of coconut oil? I hope so. But that's really the issue, because these studies are expensive. And until we can really assess them against the placebo, you don't know.
Yeah, my question is then, what would you recommend for us as a diet, and whether ketones come in a form of some tablets, or how do we get it?
Well, in terms of your general diet, try to reduce the refined sugar as much as you can. Take the pressure off insulin. Go out and walk. If you don't like walking, swim. Find some way to be active. Well, that's as far as trying to keep insulin happy, because you're trying to reduce your refined sugar. If you still insist on having a piece of chocolate cake at supper, go and work it off afterwards by taking a walk. There are various ketone supplements, and assuming that what's on the label is really what's in them, and that's not always the case, then gram for gram, they're probably pretty similar, broadly speaking. So if you prefer to take a salt in a packet and put it in your coffee, that's fine. If you prefer to have it in a liquid in a milkshake and you want something that's cheaper, then you can take an MCT. If it's got C8 in it, it's going to be ketogenic. There are some C8 products out there. Sorry, I don't know who has the mic, but...
I got a blip from a friend of mine when she found out I was coming here today, and she said that on the news, the Cleveland Clinic is working on a drug that may reverse Alzheimer's, and that it's been successful in animal trials. Have you heard anything about that?
No. You know, there's lots of people working on animal studies of Alzheimer's disease. And there's been a lot of success stories in animal studies of Alzheimer's disease. Unfortunately, almost none of them translate to humans. So it's wait and see. Maybe they're onto the real thing, but I don't know what the context is anyway.
Have you come across data on cell cultures? Here we go.
Sorry.
Looking at neuronal cell cultures exposed to ketones versus other media cultures to see if it improves survival or if it improves longevity of those cells, or if that study's been done?
We certainly don't do them. I don't have the technology to do it. Perhaps someone, Dom, do you know the answer? Yeah. Maybe you could take the mic.
So your question was if ketones are neuroprotective?
In neurons, in culture?
Yes. Under conditions, especially where there's glucose deprivation, the administration or adding ketones to a petri dish with cultured neurons will they're very neuroprotective in that context. And regeneration too. Recently, we've shown some studies where there's an enhancement of regeneration, which is the neural sprouting and the axons actually growing out of neurons.
Thank you. Good.
My question is, what do you look for in a supplement that, shows that it's a quality supplement and not?
That's a challenge because there are fraudulent products out there, and even if the company genuinely believes that what's in the bottle is what's on the label, they may not always be right. So what do you look for? I mean, you can pay, I'm sure, some independent laboratory to do the analysis, but in the end, some supplements are not going to contain the active ingredients that you're hoping are there, or in the amounts that they claim. And that's the state of the art. Don't put all your energy and money into supplements. You can walk, the cognitive stimulation, improve the diet as well. There's no miracles in this business, so there's no single supplement or even a whole pile of supplements that are going to be the solution by themselves.
In a planned diet that we subscribe to, it is considerably inclusive of fruit. Now, does fruit, in the sense of production of glucose or sugar or whatever, is fruit within the refined category, or is it detrimental by having a diet of fruit?
Well, fruit kind of sits on the fence. And I mean, there's nothing wrong with eating an apple or a banana or as much as you want of them. But if the fruit comes in a can or, you know, it's in some way modified, chances are there's additional liquid or fructose around as well. So you got to use your best judgment and eat some fruit.
Okay, if it's just fresh
But you don't need to eat fruit for the vitamins, for instance, or the minerals. The ketogenic diet has very little fruit in it. And you can get the vitamins and minerals, particularly from vegetables, leafy vegetables.
Okay.
So if your goal is to get the vitamin content, you can do without the fruit. If you like the fruit, if you like blueberries, I mean, go for it.
Thank you.
Excuse me. Okay.
Are there any negative effects of taking a tablespoon of MCT oil every day?
Most people are not sensitive enough to have a negative effect from a tablespoon, which was the unit you gave me. You don't want to take this much MCT at one shot, right? You can work up to 50 or 60 grams, so that 60 grams would be about 2 tablespoons. Start slowly. Find out if your stomach is actually quite sensitive. Some people are less sensitive than others. So there can be side effects, but you can dilute the MCT. You can take it 2 or 3 times a day. You don't have to take it all at once. In fact, it's better. Even if you had no side effects, it's better if you spread it out because it allows the ketone levels to last longer in the blood, and that's what you're after.
But there are no negative effects on your body.
There's no danger apart from the risk of diarrhea from a large dose. Some people are constipated and they actually look forward to it.
Okay. Do you want to be ketogenic enough to have ketones in your urine to do this, like on the Atkins diet?
So my experience with the ketogenic, measuring ketosis from the ketogenic diet is from epilepsy in children, and it's notoriously useless. It's not a very good indicator because your urine volume is going to depend on how much you drink. And the concentration of the ketones is going to be the opposite of the volume. If the volume is big, the concentration is going to go down, but you might be excreting a fair amount of ketones anyway. So it might be simpler in some ways to use the urinary sticks, but I don't think they're a good indicator. That's my experience from the ketogenic diet for children, and it probably applies in adults as well.
Okay, we have one last.
If you really want to know what's going on with your ketones, you can do a finger prick measure. It's not that expensive. Sorry.
No, we have one last question here, sir.
Since the human brain's about 3 pounds plus or minus a pound, and we're told for years now, avoid fats, and we know that the brain atrophies as we age, what about omega-3 for the brain? Will that make a difference over time?
So what's called the epidemiology, which is the way people eat that eat fish, countries where fish is eaten have a lower incidence of Alzheimer's disease. Japan, Norway, Portugal, etc. Countries like you-know-which that don't eat much fish have a higher incidence. That suggests that fish is protective, and I don't challenge that association. The problem is if you don't eat fish, and I tell you you should eat fish, you're not going to. That's the first thing, and you're going to try and replace it with fish oil, which seems like a sensible compromise. But all the randomized trials with fish oil capsules in Alzheimer's disease and in mild cognitive impairment have not been successful. So does that mean there's something in fish that you can't put in, but it isn't in the capsules? I'm not sure, but that's the state of the art. We're trying to boil down food into capsules and supplements and stuff, and maybe that's not the solution. Of course, if you've never eaten fish and you're not going to, then you can eat omega-3 fatty acids from algal sources. You can eat vegetarian sources of DHA because alpha-linolenic acid from flaxseed oil is inert in terms of DHA production. You're not going to make any DHA from alpha-linolenic acid, I guarantee it. So, and everything that's leafy and green has got alpha-linolenic acid. You're going to get loads of omega-3, but you're not going to get any DHA, and there's no alpha-linolenic acid in the brain. So you need the DHA. Maybe you can convince yourself to start eating fish. But right now, it's kind of a, there's no solution. And it might depend on the energy status of the brain anyway. If there's not enough fuel getting into the brain, maybe the DHA is getting there and it can't do what it needs to do because the neurons are not communicating because there's not enough energy. And the reverse could be true. We might be able to optimize a ketogenic supplement with DHA. It's not out of the question at all. But separately, the DHA doesn't seem to be very beneficial. At doses that you would expect, if it was going to work, it should work. 800 milligrams a day, it hasn't worked. That's a lot.
I would like to thank everyone for being here at this lecture. Please show your appreciation to Dr. Cunnane.
Thank you.